Hey guys, welcome back to another video. So here we're going to go through question 4 and 5. So let's go through this walkthrough and see how it goes. Now for number 4, it tells us that we got a figure 2 and it shows the graph of y equals x minus 1 over 2x squared. So that's how the curve looks like for values between 0.4 all the way up to 5. So that's just the domain of the graph. Now the question wants us to express this part of the equation as a single fraction. So let's go ahead and do that. When you want to make anything as a single fraction, you must always have a common denominator. So in this case, we got 2x squared. So the first one should be over 2x squared. And to do that, you just multiply up and down by 2x squared. So it'll look like this. So you're going to have it basically x times 2x squared over 2x squared minus, and then just copy the other one, 1 over 2x squared. And well, x times 2x squared is 2x cubed. So your final answer should be 2x cubed, and then combine it, minus 1 all over the common denominator. So that's it, that's our A done. Now moving on to the second part of A, it says hence. And now when you see the word hence, it literally means carry on from the previous question in some way. Hence, use the graph to obtain to one significant figure and estimate for the value of the cube root of 0.5. Now this is not very clear what it's trying to say, but what it really means is that when you got a graph, every time you cross the x-axis, that's the value they want. So actually this value right here is basically the cube root of 0.5. Also they say, yeah. So what we're going to do, we're just going to let x equal that value because that's where it's at. So just say let x equal the cube root of 0.5. And let's go ahead and make this value, let's go ahead and rearrange this and make some sort of equivalent expression to what we saw up there, yeah? Because remember, this is actually on the curve, so we can kind of link it to that. So just tidying this up, I'm going to cube this side. So we're going to have x cubed equals 0.5. And I'm going to go ahead and try and make it look like 2x cubed, because now you can double it. You're going to have, therefore, 2x cubed equals 1. Now the reason why we're doing this is because you want to make this equation equal to, well, y. So just understand the logic. We have y equals 2x cubed minus 1 over 2x squared. Now if you look at it carefully, if I make this, basically if I move the 1 across, we're going to have 2x cubed minus 1 equals 0. Now this is telling us literally that this equation is now 0. So all of this is basically 0. So now we have y equals 0. And this matches up perfectly because it actually lines up with the y-axis. So when x equals this quantity, y equals 0. And that's really it. So this is kind of literally what we want. And that's really it, guys. You just kind of need to show that you can kind of prove this using a graph. And now finally, just to get the answer, just pop the cube root of 0.5 in your calculator and you should get an answer of 0.8. And that's literally all they want. It says, by drawing a suitable straight line on the grid, so they've actually gave us a hint what straight line we're going to draw, find and estimate two significant figures for the root of the following equation for the same interval. Now, at first glance, we need to firstly recognize, like, does this look familiar? And if you look back at the earlier question, you can say yes. It kind of looks like, you know, y equals x minus 1 over 2x squared. We just kind of need to show it. So let's go ahead and try and reproduce this bit over here, so try and factorize it in. So what we can do, we can probably move 2x and 1 over 2x squared to the other side. So let's just take our time here, guys. So we're going to have 4 equals 2x minus 1 over 2x squared. And just to be a little cheeky here, guys, we can just, because we just want an x, let's just subtract an x across to the left hand side. So now we got 4 minus x equals x minus 1 over 2x squared, and therefore we can see that all of that expression equals y, so therefore the right hand side equals y. So this is essentially y equals 4 minus x, and that is literally our straight line we need to plug in. So let's go ahead and just draw a straight line on this graph now. So we've got y equals 4 minus x. Again, if you're not too confident of drawing straight lines, it always helps to just draw like an xy grid. Now let's just pick a value, yeah? Let's just say when x is 0, you plug in 0, you got 4 minus 0 is 4. And I'll just say pick another one. Let's just say when x is 4. When x is 4, 4 to get 4 is 0. So these are your corners. you can see your first pair of coordinates is 0, 4 occurs here. So you got 0, 4. And conveniently, the second one, when x is 4, y is 4, 0. So this is the other coordinate. So you want to draw a nice straight line. I'm not going to lie, it's going to be hard, so I'm going to draw a dotted line. I know it's going to cut like that. So you can kind of see that the question asked again, just going back to the question, it says find an estimate to two similar figures for the root. When they say the root, it means when does it cross the curve? Well, it crosses around here. So we can see that this is literally crossing around when x is 2. So that's our solution. So x is basically 2. But let's just say 2.0 because I think they said, was it two same figures? Yep, so 2.0. So if you wrote 2.0, you should get a mark. And that's it. Whew. So integration is definitely one of my favorite, guys. So let's have a look at this. Now, first one. Find the integral of 3 minus x plus 1 over x cubed. Now, before we integrate anything, guys, when you got a fraction, everything needs to be written in terms of x to the power something. So let's go and just rewrite this, yeah? We want to find the integral of 3 minus x plus, so because you got 1 over x cubed, that's the same as x to the negative 3, yeah? Always bring it back up. Now integrating that, that's quite easy. If you integrate 3, you just stick an x. If you go an x, you add a power, so it'd be x squared, and then you divide it by its power you see, which is 2. And do the same here. Because you got minus 3, add 1 to the power, so it becomes minus 2, so it becomes plus x to the minus 2 over minus 2. And never forget the plus c. And then therefore, guys, tidy up. You should get 3x minus x squared over 2. You got minus sign here, so it'd be minus x to the negative 2 over 2 plus c. And that's it. So that's our first part done. Part 2, hence evaluate the same thing, but now you got limits. So when you have limits, all you literally do is just stick a massive bracket. So for you guys, let's just continue over here. So for this would be a part 2. We say now we put a big square brackets. We copy everything in. So x squared over 2 minus x to the negative 2 over 2. And then just ignore the plus c. And then put the limits of 2 and 1 here. Now all you want to do, guys, just firstly plug in 2 over here. Replace x's with 2 and then replace x's with 1. Then make sure you show it, yeah? So the first case, you got 3 times 2. So it'll be 3 bracket 2 minus 2 squared over 2 minus 2 to the power of negative 2 over 2. And then you minus it by the same thing, but replace x's with 1. So you got 3 times 1 minus 1 power 2 over 2 minus 1 to the power of negative 2 over 2. Just check everything's written correctly. Yep. And that's it. And then you just evaluate that. That's it. Now remember, guys, you've got a calculator. So literally put this all in a calculator all at once, including the brackets. And you should get an answer of 15 over 8 or 1.875. That's it. So either one will work. Now let's look at part B here. So B says find the integral of 6 sine 3x. So I'm just going to write it over here neatly. So integral of 6 sine 3x dx. Now quick rule here. Every time you integrate sine or cos, so let's say sine 5x or cos 5x, integrating 5 sine x will always give you cos 5x, and you divide it by the inside, which is 5. And because you're integrating sine, it becomes a negative. If you integrate cos, you get the same thing but a positive, and it'll be sine 5x over the inside 5. So that's the interchangeability rule, guys. Always remember that. Now let's integrate this one. When you got a 6, you can just ignore that. So just be 6, integrate that one, so it'll be minus 6 cos 3x over 3, and then write plus c. And then tidying this up, guys, you should get, well, 6 over 3 is 2, so minus 2 cos 3x. And then don't forget the plus c. So that part's done. And let me guess, evaluate now between pi over 6 to pi over 9. Okay, let's try it out. So we're going to now put a big bracket, put minus 2 cos 3x. And the limits, as usual, would be pi over 6 to pi over 9. So what this means that your calculator should be set to radian mode, yeah? So please put on radian mode. Now, same thing like we did earlier, just basically replace x with pi over 6, and then replace the x with pi over 9 and just find the difference. So just to put it out there, you should therefore get minus 2 cos, and put a bracket, 3 times pi over 6, close bracket, take away, minus 2 cos, open bracket, 3 times pi over 9. So that's how it should look like in calculator. Do that, guys. And just like last time, guys, don't bother working this out. If you got a calculator, use it, yeah? If you put this all in the calculator, you should literally just get an answer of 1. And that's it. This is your final answer for number 5. But yeah, guys, thank you for watching my video, and I hope to see you guys next time.